Subscribe to AmpCode and ring the notification bell to get the latest content.
So now let's discuss about one exercise that we are going to see in this lecture. So basically the first step of our Spark streaming application is deciding the source from where we are receiving the real-time data. So for simplification purpose and your basic understanding, let's not go into much complications where we are getting when we are going to integrate Kafka or we are integrating Flume, Kinesis. Let's stick to the basics. First, let's try out the socket connection method. So this is very simple. We just have to have a socket connection to some port where we can publish the data in real time continuously. So basically our Spark streaming application will listen to the socket connection that we made on that particular port for the new upcoming records or incoming records, and then it get processed in using the data frame operations. So we can say like the word count. So basically we are going to stick to the word count example here. So let's say this is our NC. So we are going to publish some data through command line using the nmap or ncat capability. So for that we just need a simple tool which we can easily download and install on our system. So that we are going to see next. So here we are going to install the nmap software on our PC so that will get us the capability to connect to that socket connection at that port and publish some data in real time. So basically as you can see we are getting the result. So we have submitted few lines. We have the cat, dog, dog and dog on the second line. So these are two lines, and on the time interval 2 we got the owl, cat and so on. So we can publish any data through that command line. So basically these are the three time windows that we have defined. So let's say we can process the data for every 2 seconds. So it will listen to that 2-second window and get the data from our socket connection and then append them into that data frame, or we can say it as an input table. So basically this is our input, which is nothing but an unbounded table of all the input. So let's say this will be our data frame 1, then this will get appended. So this owl and cat will get appended to our input table, and at the third interval the next input, which is the dog and owl that we have submitted. So these two rows are getting appended to our input unbounded table, and we are going to apply the query. So basically our query is to get the aggregated output of all the words here. So as you can see, the table of the word counts will be our output result table, which we are going to see on our terminal. So the output will be the complete mode here. The whole complete output we will be getting on our terminal. So this is very simple example. So let's jump on to the coding part and also install the nmap tool in your system. Okay, so this is our script. So the first step is you have to import the Spark session from the pyspark.sql. Since we are dealing with the Spark data frames here and we want to implement the Spark structured streaming API. So, and here we have to just import the Spark SQL functions, and we can import the all functions because we will be using few functions in this code. So the first step of every Spark application is the Spark session. So here we are creating the Spark session. We have the builder method, and so to build the Spark session, and we can give any name to our application name to easily track that. And also we can use the get or create method to get the existing Spark session or create a new one for us. So the first step is you have to provide like the input source where you are going to fetch that real-time records. So this could be like the connection to the Kafka, Kinesis, Flume, but in here let's keep it simple and let's listen to the socket connection on some specific port. So basically here our Spark will have the read stream. So the lines is nothing but our input data frame. So this input table will store the data from the read stream method. So we were using the spark.read method to read the data from any CSV file or any stationary source for source of the data. But here we are going to use the read stream operation. So you have to remember the read stream operation is for the Spark structured streaming, and the read operation for reading the data into your data frame, which is stationary. And also here we are giving the format. So earlier we were used to give the format as CSV or Parquet or JSON, but in here we are having the data from socket. So here, so as we have discussed, we are going to listen to the socket connection, And in socket connection, you have to give some argument. So the first thing is the host. So I have put the host as a local host because we are installing the nmap in our local system, and the port is 9999. So this Spark session will listen to that port for any upcoming data or any incoming lines so that it can proceed it in the further step. So the next step will be the query phase, where you are applying the logic on top of those small streams, or we can say it as the appended rows into your input table. So this will be like your input table, and this we have to transform the data. So in our example, as we have already seen, we are going to count the words which are coming from the lines. So first, our lines needs to be converted into words. So there is a simple function which is like the split function. So it will just get the lines out of the data frame and it will just split them into words. So basically the words data frame will have all the words, and we are again going to aggregate them. So basically the counts data frame will group by those using the word, and then it will be counted out. So the count operation will nothing but counts the instances of the words in that data frame, or we can say the words data frame, and it will store that aggregated output in the counts. And the next thing is very important for understanding the fault tolerance of the Spark structured streaming, which is the checkpoint directory. So checkpoint directory is the best feature which ensures the Spark's fault tolerance behavior. So basically, let's say if our Spark application died unexpectedly due to the hardware failure or any unexpected results, so in that purpose, it should know where the Spark application has failed, and from that instant itself, it should continue reading the data from the incoming real-time sources. So to ensure that that particular information will be stored as a checkpoint directory. So in this checkpoint directory, this could be anything. So this could be your file system, this could be your SDFS, or any data source where you can store some data. So basically, as I have given here, the checkpoint directory is nothing but the location where the status of the application will be tracked. So if our application has failed due to some unexpected reasons, it will continue from that instance where it got failed, and those details will be present in this checkpoint directory. So since we are triggering our job in the local system itself, we are giving the path as we have created the checkpoint folder in the C directory. So this will be our checkpoint directory, and we have to define the necessary configuration for starting our streaming application. So for this, we have defined our input sources, which is nothing but the socket connection and also its configuration. Then we have transformed the data and also defined the query for our input table, and also we got like our output table, which is nothing but the data frame where we have the aggregated output. So basically we have to write this data and also start our streaming application. So for streaming query, all you have to do is we have to just use the count. So counts is nothing but our final data frame or the final output. So this final output, we are using the write stream. So if you remember, you have like the spark.write method or the data frame.write method. So this write method will write your data into some external sources or the HDFS or anything, so you can write that data anywhere. So it could be like the HDFS S3 bucket or any database you want to store. So the format would be like the console, because we are getting the results on the console so that we can monitor and see the simulation of the real-time streaming application. And also here we have used the output mode. So as we have already seen, we have the append mode, complete mode, and the update mode. So basically, as per your requirement and the use case, you have to define the output mode here. So since we are dealing with very small data, we are not able to deal with the huge data sets coming in at high velocity and high volume. We are going to use the complete mode. So it will get all the results in the complete mode in our output table or the data frame. And here we have to define the processing time for our trigger. So in the trigger, we will having the argument as the processing time. So this time window, which is nothing but we have defined the 1 second window. So for each second, it will check the records present in the socket connection, and then it will start processing it as per our logic. So the query is nothing but just selecting the words from the lines and then aggregate it and get the counts as per the words. And also you have the option for defining the checkpoint directories. So to ensure the fault tolerance, giving this checkpoint directory is very crucial in your Spark streaming application. And also you have to use the start method. So if you remember correctly, you are using the load method and the save method to read the data and write the data. So here we are using the load method for read stream, but you are going to use the start method for starting your streaming application. So here we are using the start method, and also we will just use the await termination to able to continue with your streaming application until it gets the signal for termination purposes. So basically this code will listen to the socket connection. So socket connection we are going to configure now, and then we will kick off this application. So it will continue checking for new records and process them in real time, and we will get all that data into console. So this will be really fun. So first let's set up the nmap in your system, and let's push some data through that socket connection at this 9999 port. Go to your favorite browser and just use like download nmap. So it will give us to the org page of the nmap. So just give the free version of the nmap. So nmap is totally free, so you just have to get the nmap for your system. So it is like Windows for me, and also for Windows installation we will give like the latest, which is like a stable release of the self installer, which is the .exe file. So once you click that, you will get this done. So as you can see, it's only 31 MB. So just click on the installer and the process will be really straightforward. So you just have to click on the agree, and then you can just give it as default as next, and also you can give the install here. So it will be like the 5-minute task. So once it is completed, you just have to go into the command prompt and write and start publishing the records through the command line. Okay, so it got completed. So just next and just finish it. So this was really simple. So to able to check the connection to your 9999 port, you just have to open the command prompt. So I'll just open the command prompt here. So after opening the command prompt, you just have to type the command as ncat and then -l and give the port as 9999. So this will be the only argument, and once it is done, there you go. You are now connected to your socket connection at this port, and you can publish the data. So before publishing, let's kick off our Spark application to start processing that data and listening to this prompt or this connection and process that data in real time.
Okay, so just kick off our job. So it will listens to that data for every second in our socket connection. So as you can see, our job has been finally started and listening to our socket connection for every second. But we haven't inserted any data into it, so it will not give us anything. So let's check on that now. So it will just completing its transformation and all. As you can see, we haven't got any words and the count. So it is like 0. Okay. So we will just submit some data in this port connection. So all we can do is we are learning pyspark. Okay, so we got some data and it is now processing it. So let's see what it gives us. And there you have it. We got the V output and we have got the count as well. Let's see if we get the other data as well. And yes, we got all the data. So here we have we are learning Spark. That's it. So once you start submitting the data, it will just split those lines into words and then give us the aggregated output. So we are enjoying the learning. That's it. So once you submit the data, and there you go. We also got the result. But here, since we have given the space, it is only giving the V and comma as well. So we'll just again try to submit it, some words, and let's wait for it to complete. And there you go, we got the V word which appeared 4 times here. So this V is with the comma, that's why it's given the separate result. But I hope you understood what we are doing here. We are just publishing the data through the socket connection using the netcat to the port 9999, and then Spark is consuming that data, converting it into words and giving us the count of all the words which is having. So we have submitted the learning twice, enjoying once, and all the words, which means that it is giving us the expected output. So I hope you understood it and enjoyed it, and I've given you the link for installation, the ncat as well as this spark streaming.py file to you, so that you can get your hands dirty and build your own Spark streaming application. You can listen to anything. You can listen to Kafka as a source and you will sync the data to the console or either the file location that you need, but make sure to give the checkpoint directory because it is very important for failure recovery. So I hope you got all the understanding here about Spark streaming. So that's all for this lecture, and let's discuss about some theoretical stuff of how it is working under the hood in the next lecture. So that's it for today. I'll see you in the next lecture.